This event is brought to you by Women in 3D Printing, Next Generation. And the objective of the panel is to inspire women to join the 3D printing industry, specifically today for the construction sector. And we're going to discuss some diverse career paths that you can explore. And we want to extend that inspiration and that greatness to all the audience with all the amazing speakers that we have today here. So without further ado, we're going to do a quick round of introductions. So we're going to start with me as a moderator. Hello, my name is Sofia Lopez. I am Women in 3D Printing, and I used to volunteer at News Story organization as well as a research and R&D fellow for industrialized construction. And I've also recently joined Stefan Mansour's group, creating the baseline of 3D printing construction regulation. So I am very excited about this event. I have experience in construction, specifically in the energy sector, building hydrocarbons facilities. And that's the quick introduction for me. So we're gonna go to Melodie. So Melodie, if you could please introduce yourself to the audience.
Okay, hi everybody. My name is Melodie Yashar. I'm the Director of Building Design and Performance at ICON. What I do at ICON is I direct a small team that focuses on architecture and building science and looks at whole home performance and the integrity of the housing solutions that we provide to our customers in the various applications and projects that we work on at ICON. So how I got started in 3D printing, a little bit of backstory in me. My background is in industrial design, architecture, and human-computer interaction with an emphasis in robotics. So I've jumped around in disciplines. I started out as a designer, interested in 3D printing, really because it's at the time I was in graduate school, it was like the most interesting topic at the intersection of design and technology. A former group that I was a part of submitted to NASA's 3D Printed Habitat Challenge, which was a centennial challenge that kicked off in 2015, soliciting the general public for design concepts for a 3D printed habitat on Mars. My group ended up winning first prize in that competition and subsequently went on to win first prize again in a number of other levels. And that was really my my entry into the intersection between space and designing for space and how 3D printing can apply in the future in space. Now at ICON, we've recently announced the Mars Dune Alpha project, which is the image that you see in the bottom of the slide, the lower half of the slide. This is an analog habitat that's currently in construction at the Johnson Space Center in Houston at NASA. And what we've done in collaboration with the Bjarke Ingels group is we've designed, programmed, and now are constructing a habitat that will house a crew of 4 crew members to simulate a Mars mission, simulate what it would be like to live on Mars over the course of 1 year. We just finished the walls of this structure and we're moving on to the roof. And the simulation will probably kick off in fall of 2022. So that's a little bit about my backstory and what I'm working on today.
So now we go with you, Anna. Thank you.
So my name is Anna. I'm the CEO and founder of Apis Cor. We are the developer of the one-of-a-kind 3D printers to 3D print houses, like a full-scale houses. I understand everybody knows how it works, but when you tell people that you 3D print houses, they're like, you 3D print what? The small houses? No, then you describe that. You 3D print full-scale houses on site. And so basically how I get there, I studied space physics. And almost at the last year, my education at the university, I met my co-founder, Nick, who actually developed the printer later on. But long before that, before Apis Cor, we were involved in the construction business. And so here you can see the pictures from the very large project that we executed long before Apis Cor. It was the project of the designing, fabricating, manufacturing, and deploying the ground navigation system for the visitors of Olympic Games in 2014. It was almost more than 5,000 signs that you see on the picture. It was a different designs, and it had a very heavy concrete basis that actual information was attached to. And so also on the bottom picture, you can see it's about 500 very heavy concrete stuff that's part of this navigation system. So that was the first very challenging project that we did as a part of the construction industry, because we had to manufacture, actually design, fabricate, and manufacture this massive amount of stuff in a different city in a very short timeline, like 6 months. And so that actually brought us show us how the construction industry is so outdated, because even we was not really involved in the actual construction. We were part of this because sometimes we saw how the construction projects were not done on time, just because construction industry heavily rely on the human labor. Everybody knows this. And so because of the construction project was delayed, we could not deploy some amount of signs, and we had to reschedule entire everything, entire logistic, just to keep up on time. So anyway, after this project, we realized that it's really outdated, and this is how we decided the automation has to be introduced in the construction. How are we gonna do this? And this is how we landed with the Apis Cor, developed the advanced and unique 3D printer which features mobility and portability that really provide a lot of opportunities for construction and how to actually bring the automation to the construction. And so this is basically very short about me.
Thank you so much. I'm sure we're gonna get into the details further in the panel of that building that you're presenting. So we're gonna go to the introduction of the next panelist. So Alma, please.
Thank you, Sofia. Hello, my name is Alma Bangsgaard, and I'm an architect at COBOD. We are situated in Copenhagen in Denmark, and we build large-scale 3D printers. As you can see on the pictures on the left, on the bottom picture, you can see one of our printers, and on the top, you can see one of the houses that's recently been completed, done by one of our printers for one of our partners, Petr, in Germany. We have customers in a lot of different continents, both in Africa and Asia, Europe, US, and so on. And one of my many main tasks at COBOD as an architect there is to help our customers design for 3D printing, and how do you convert your designs into something that you can actually 3D print. So all of these technical details and the digital modeling that you have to do, that's kind of my specialty there. I got into 3D construction printing because I dedicated my entire master when I was studying architecture to 3D printing, where I built the 3D printer you can see in the picture here, which is a 3D printer for clay, where I then did multiple both architectural and artistic projects with my own machine. And I was very much focused on both the tools and the process. So I made my own slicer, made my own machine, all of these things, really getting to know the process. And this was all very DIY based, and that's how I got into 3D construction printing. Luckily for me, COBOD was just in the backyard, and here I am. So yes, that's a quick introduction to my background.
So much, very impressive. You built the 3D printer yourself. So I'm sure we're gonna dig into design further in the panel. So thank you so much for your introduction. We go to the next panelist, please. Hannah?
Hi, my name is Hannah, and I am a rising junior at the Massachusetts Institute of Technology, double majoring in mechanical engineering and creative writing. So for the past year and a half, I've been with the Mediated Matter Group, which is a lab in the MIT Media Lab, researching the 3D printing of biopolymers, which are natural and biodegradable materials. The Mediated Matter Group fuses sustainability, ecology, material science, and art to promote unity between nature and man-made designs. So how I got involved with 3D printing, I'd always thought it was really cool. And throughout high school, I dabbled with like the traditional tabletop 3D printers working on small projects. But once I came to MIT, my whole idea of 3D printing expanded when I saw what other students were working on, saw all the labs, and saw all the research taking place. The Mediated Matter Group in particular was so inspiring and impressive to me. Seeing all their projects, since I'm an artist, that emphasis on creativity and art blending with the sciences was so exciting, and I really wanted to get involved. So now throughout my research, I've been learning so much, and it's definitely fueled my passion for 3D printing, and I'd love to go into the industry after college. So very excited to be here. And if you take a look on the slide, you can see some of my final projects from this semester. So we have a lot of very colorful biopolymers, and I've been kind of combining art with practical applications. So by creating these fun pieces of art, I'm testing the properties of the materials and programming the printing parameters of our printers to learn more about the fabrication process and the materials themselves. I've also been doing some prototyping with multi-material printing, exploring thermoforming, and a lot of the different applications of 3D printing in general and these biopolymers. So that's just a little bit about me. I'm really excited to be here and looking forward to hearing from the other panelists and meeting all of you. Thanks so much.
Thank you, Hannah. You are the university that is joining us. We have other companies, so we're very excited to have this combination of very talented people, including you, with all of these amazing materials. So you're going to give us further details after, but thank you so much for your introduction. So we go with the next panelist, please.
Hi, everyone. My name is Agnès Petit, and I'm CEO and founder of MOBBOT. MOBBOT is a Swiss startup, so based in Europe, Switzerland. And my background is, and how I came to is that originally I graduated as a mining engineer. Then I pursued my PhD in cosmochemistry. So I was dedicated to space science. I worked on extraterrestrial material 15 years ago. And for personal reason, I decided to switch to the construction industry. At that time, I was already with my husband, who's an architect. So I was listening to all his issues that he had on the job side, the delays, and I said, well, no way that I will enter this industry. But with my background, I thought that maybe with resources, I could help to use resources more wisely. So I joined a very large cement producer, which is called Holcim. And that's how I started my career in construction and building materials. This was 15 years ago. I was developing new type of cement, concrete worldwide for Holcim. I understood and had an overview of the difficulties on the job site. And then I decided to take a more operational role at a precast plant in the precast factory. I developed there a new product for 3 sectors, for infrastructure, buildings, and landscaping. At that time, I was generating 10% of the turnover of the company with new product, but I was facing always the same issues, the molds. And every time we had an infrastructure project, the timing was extremely tight. We were facing always delays in the production. quite a lot of stress, and that's how I came to 3D printing. So maybe 5-6 years ago, I started doing what, in my eyes, I say conventional 3D concrete printing, what I think the other panelists are today doing, extrusion of material. And then I started doing that, but it was not answering my needs as a precast in the infrastructure. So I switched to a different type of application, which was, I had to look at what is being done today in tunneling. And that's how I decided to found MOBBOT 3 years ago, where we are bridging actually sprayed concrete used in tunneling with robotics and sensor. So we are today focusing essentially in infrastructure, utilities, application, and we are developing this new type of additive manufacturing using high-speed sprayed concrete, which gives super high performance in terms of tensile performance, but as well the possibility to integrate reinforcement. And we are providing the technology, or we are providing the 3D printer. It can be moved, it can be placed also on the job site. And we are essentially today focusing on the infrastructure and exploring what we could do there. You see on the top pictures also an element for a bridge. And so we are really like trying to see how we can help contractors to use 3D sprayed concrete for bridges, utilities, but also tunneling. And I'm looking forward to exchange with the other panelists today. Thank you, Sofia.
Thank you, Agnès. This is incredible, as you not only joined the industry, but created a company in the industry. So I'm sure you're going to be telling us more about that shortly. Thank you so much for your introduction. And now we're going to move towards the other panelist. Thank you. Hi, Sonya.
There we are. Well, first off, putting this panel together, every single woman on this panel is just amazing, and I'm just so honored to be a part of it. So thank you for putting that together. I'm Sonya. I'm from MudBots. We're based out of Utah in the United States. I'm just the manager here. I'll get to what our company does, how I got into the industry. So our company, what we do, we build printers feet to 10 feet all the way to 100 feet by 100 feet. Be very user friendly, lightweight, easy. And we do also have our own slicing software. So it allows you to use pictures. You can do some really cool textured effects. There's some of the examples that you can do. So you don't even have to finish the wall. You can, if you have a small crew, especially a woman, which we'll get into later, it's really easy to just print it and then be done with it. We are designed to do multi-story in your basements. So if you need to do second story or your footings, we help with that. We don't use a proprietary mix. And I've had a couple of questions from, I saw in the chat, as well as our networking 15 minutes. We don't use proprietary mixes, so I know eco-friendly and sustainable is something people's radars right now. With that in any way that we can. So we help you with formulas to use whatever material you figure out that strength, so we can putting it prints correctly. On my end, thank you. Let's
yes, Sonya, you could help
Is
us
that
there
better?
a little bit. It's a little bit cut off. Yes, that's a little bit better.
Much better. Okay, thank you so much. As far as my background into the industry, my background is actually the entertainment industry. I had no intention to get into this industry. I didn't even know it existed. I started here about a year ago, and I just answered job listing, answering phones, and then it became a passion. first line of defense, talking to all of our customers moving forward or worldwide. And I really sit down with women and men and try to figure out how we can bring affordable housing to their area. I am there by any means, so I know pretty much the basics, especially with the when we get. But that's kind of my industry. It was entirely by chance, and it turned out to be kind of a passion.
Okay, so now you have seen all of these amazing women that we have here. We are very, very excited to start the discussion. We're going to start with Melodie. How is 3D printing taking women work to another planet?
3D printing is envisioned as a leading construction system, construction technology for how we will eventually establish permanent infrastructure, structures of all sorts on the moon and Mars. And one of the ways, excuse me, one of the ways that space technology development advances for 3D printing is by using terrestrial construction or building on Earth as a test bed for what will eventually be deployed in a mission scenario in space on the moon and Mars. So one of the projects that ICON has sort of initiated in the last few years is known as Project Olympus. This is our intention and our goal to deploy the first automated construction system on the moon that will be able to 3D print roads, landing pads, and eventually habitats that can shelter a crew over the course of a mission. We have a long way to go before we actually get there. No one has been on the moon in the last several decades, but at the same time, the technology development that we actually use and that we actually deploy for terrestrial construction, residential construction on Earth, applies directly to the technology development and the kind of systems engineering that we introduce for building in space. So in our opinion, development for space is always going to be beneficial and is always going to come back and loop back around to introduce benefit for Earth.
Great, thank you so much. So we have some pioneers in the call, all of you, but you know, this is building beyond Earth, so it's always exciting. Great, so thank you so much for your answer there. We have a second question, which is how space restrictions teach us more about how to build better in Earth.
Space restrictions, do we mean like constraints in terms of like code and regulatory? I think that well, okay, fundamentally, I think like philosophically, I think that design is about working with constraints. There's never going to be an opportunity where we can design separate from physical constraints, mechanical constraints, or budgetary constraints, time constraints. We're always going to be limited to a certain extent by the real world parameters that are going to generate or result in some kind of project, right? So I think constraints are a key part of what it means to be a designer and what it means to innovate in this new space. But specifically when it comes to construction scale 3D printing and building construction in general, we want to work with regulatory officials, with code compliance officials. We want to work with the current systems to actually have adoption for this new technology move further faster. So we're not working against current kind of building code and I guess you could say regulatory standards. We want to be working in such a way and developing our research in such a way that this technology can expand and can be adopted nationwide and worldwide.
Like what you said there, it's true. We always work with some parameters. Certainly these ones are quite relevant or new, unusual, but I'm sure you guys are going to do a great job. So thank you so much for sharing that with us and your. Okay, now Anna and now we have outside of Earth. There's some comments or exceptions in general to say, okay, so how real is this? So the first question that we have for you is, can you tell us if scalability is too far in the future? What could you share with us about your perception of scalability in 3D printing construction?
Yeah, very interesting question, and it's really like something that's very actual today. So first of all, that's really happens today, and we cannot like avoid to admit this. Today we see a lot of houses printing here and there, and more companies starting doing this. So it's real. The answer is it's real. The another question is like the scalability, right? If something real, it doesn't mean that it's inevitably scalable. And actually, first, it depends on the actual technology that you use, right? Because it makes sense to scale something if it makes sense to be scalable. And so when we talking about 3D printing technology, it does not mean that all of the solutions are the same. So I can really speak about our solution that's really different from others. And that's the question, like what the technology really makes sense to be scalable. And to answer this question, you need to understand the basic budgetary and constraints and what really makes sense for this technology to be easily used by customers. And so whether the robotic solution or technology equipment, let's say, how much time does it take and how much money does it take to bring the printer from one location to another location, right? Does it require cranes, pallet jacks, forklift, 10 people to assemble or disassemble the machine? How fast it can be set up on the construction site? How much efforts from people it takes? Do they need to be very professionally skilled to operate the machine? How hard the technology for them to use? All of these puzzles, it's actually go to the matter of scalability. So once we decide which technology really like has chances to be scalable, then you come to the another stage of the matter of scalability. How fast it can be available and accessible, and basically if people really know about this and are they educated about this, do they understand how it works? Because I believe nobody today have problems with the demand, interest, and incoming inquiries to 3D print a house for them, whether from construction companies or from regular people. So today the market really wants this. And but the challenge with the 3D printing technology, because it's hard technology, meaning that it's intersection of robotics, hardware, software, material science, building codes and regulations, and also it's the real world. It's not like a software that we know can be very easily scalable. So it's really like a different thing, and it does not mean that the construction 3D printing technology cannot be scalable. No, once we have the right technology and understand how to do this, it just takes more time, a little bit more time, because you need to understand how it works, what the best way to introduce it to the market, and how to really make this technology really easily usable by the customers, right? And so basically the answer that yes, the 3D printing technology is something that we need. It just right now, the state of the industry in a very, very advanced situation. It's not something that been 5 years ago when everybody was saying like, oh, what 3D printing houses? It's science fiction, how it works, I don't know. Today it really happens. And now all of the companies done a lot of work to really like move it forward. So I think that it's right now just a question of a couple of years to really, not to start, but really like, okay, when people asking, is this house 3D printed or not? So I think that it's really like a question of a couple of years so far. And what we, for example, done to scale this technology is work for the building codes and regulations. So when we started talking to the authorities and say like, oh, this is the 3D house, we're going to print this, they really didn't understand this. And then we realized, okay, that's fine, because it's everybody's think that 3D printing technology, or thought before, that it's something like it came from aliens and everything should be changed, how to do the roofing, how to do reinforcement. Everybody thought that it's really new. But then we realized that, okay, we just need to present the technology in the way that it's becomes very, very familiar to something that already existed before. This is how we came up with the approach of the concrete masonry unit-like 3D printed wall structures. Basically, we structurally mimic concrete masonry unit wall, and that means that automatically all of the other structural parts of the house, like a foundation, reinforcement, roofing attachments, everything, insulation, finishing walls, everything then the same as concrete masonry unit wall. And when you talk this way with the authorities and building officials, like, oh, okay, yeah, I see it. And then you present the drawings when the actual architect and the engineer stamp them and say, like, this is how it's gonna work. And they like, oh yeah, sure, we don't see a big difference between CMU and 3D print. We see that it's actually CMU. And also, you need to provide the test results, and you cannot just say this is like a CMU. You need to provide some data, because building officials and engineers and architects are people who speak in a data language and test results. So this is the part of the scalability as well. And then another step is the availability, like how fast companies can produce more printers. And this is another question of the scalability of manufacturing processes. We all know that what is the manufacturing hell, right? So this is another stage of where the company have the product developed, ready to go, and now they need to come from the stage of the few prototypes to mass production. This is completely a whole nother story for the company itself. So speaking, like in this case, if it's real or scalable, it's not a very simple subject, I would say. It includes a lot of different matters: technology perspective, company development, manufacturing, investment, everything. But what we really can say that, yeah, today it's something that exists and have a very solid argument to exist and proven actually that, yeah, that's done. Our building in Dubai, for example, we 3D printed a huge building there because we wanted to show that 3D printing technology, it's not only for, let's say, small affordable houses. We wanted to show that 3D printing technology is for the luxury or commercial buildings, something really unique, something really different from the regular buildings.
So this is
too narrow.
I'm sorry, this is the Dubai building that got the Guinness World Record, right?
Yes.
This is the largest 3D printed building. It was issued. Okay. Yeah.
Yes,
so
exactly.
I understand you are presenting to the authorities the comparison between CMU and 3D printing, so it's easier for them to relate how the transition happens, right?
Yes, exactly.
So that's a scalable. So we know it's a reality. We know there are some big buildings, and it's something that is not science fiction anymore, which is really good for a lot of people to understand, because there's a lot of doubt still sometimes if it's real, if it's there yet. So it's great to hear that it is. Now, a second question that was brought by the students group, because we are reaching to universities and everyone to gather women that are interested in the industry, is if I am a student and I don't know where to start, where do I learn more about this 3D printing construction topic? Could you tell us about the offer that you have in order to educate? You mentioned sometimes people doesn't really know about the technology. So if you want to share a little bit more about that, please.
Yeah, absolutely. Education is also part of scalability, because even people get excited, but then construction, it's not something that can be done based on excitement. It's all the time about the numbers, actual facts, how this work, how that work, what should I do, how much money I should invest. So then the education starts. And so it's not only for customers or potential users, it's also for the building authorities and building officials, because they first need to understand how it works. And so basically pursuing this strategy, we put together the Apis Cor University. And so the first online course is already available. A lot of people went through this, and they're very happy and saying like, oh, right now I understand much more about 3D printing technology. Because before we put together Apis Cor University, it was only like online articles written by people who never 3D printed a house, basically. It was a few people that really did something, but internet is really flooded with all of the just media highlights or something like this. So it's not really like a practically proven something like this. So Apis Cor University is the best place to start to really like what is 3D printing technology? What other solutions? Because we're not talking only about us. How it's different from the regular construction? Is it really make sense to switch to 3D printing technology, or it's going to be just part of this? So this is the right place to start, just to understand the basics. And then we are working on to add more and more online courses. The next one is going to be about the actual construction from A to Z, where we are going to share the project that we are working on right now in Missouri. It's part of the very huge partnership soon. So the huge announcement is gonna be done very soon. So Apis Cor University, it's from us, and we speaking from the experience, and we just share what we learned so far and how we see this. And so if you're the student, start with the Apis Cor University, but then it's better to get real experience in some actual 3D printing company, be an intern or like pursue the career there. I don't know. So yeah, this is the best.
Thank you so much. And we're going to talk about those opportunities at the end part of the panel. We're very excited. Thank you so much for sharing this amazing resource. We know sometimes that even with the years, there's more and more information available online. But as you mentioned, you know, we are learning where to look. So we know that there are a lot of videos on YouTube. We know that now we have this resource available. So it's just great to know that if I am curious, there's a place where I can go, ask the questions, and the technology has evolved more and more to have resources available for students in general. So thank you so much, Anna, for that. Thank you.
Thank you, Sofia.
Now, we're going to go with the same order that we had the pictures on the main slide. So let me check. So we have Alma now. So Alma, hello. We can hear you well. Thank you.
That's good.
So Alma, we have these questions that are specifically related with design and the opportunities that the technology design. So the first question was, how is this technology revolutionizing architectural design, like construction, engraved, low relief, all of these super high-end custom design items that were maybe very expensive or very hard to get in the past? What could you share with us about that?
Well, you mentioned a lot of the things that are possible, right, with 3D printing, and there are definitely some things where, you know, it would only be possible to do these things with 3D printing, I would even say. And I think in terms of kind of, you know, actually getting everything that 3D printing in construction can offer, we both need people who can design for this way of construction, right? Like now I come from an architectural background, and actually educating people into like, how do you design for this kind of building method, right? Like that's one of the things that are like very important in this case, right? And I think that also right now, this is also kind of related to actually one of the questions that I had the Q&A now that says like, will 3D printing construction compete more with conventional construction primarily on a cost basis or a functionality basis? And I believe that right now, because it's still kind of in the early stages, right? 3D printing in construction, kind of, you know, then right now it's very much focused on getting this method to compete on a cost basis, right? Because it is construction after all. Like there is a lot of, you know, budget stuff involved. So it's very much about getting it to a level where it can compete, right, with other methods. But then I think we will more and more see, you know, the method being, you know, taken to its full potential, because there are definitely things that we will be able to do with 3D printing that we would not be able to do with any other method, right? As you mentioned, let's say a double curved wall, just as a simple example, right? In order to do that, you would need quite complex formwork also. Usually, if you wanted to cast a concrete wall with such a shape. So there we're also talking about, you know, questions about waste also, right? That you would be able to do things with 3D printing that would, you know, kind of, yeah, create a lot of waste usually, but now we're able to do these things without any waste, right? So that's just like for like the global shape, like more like on a macro scale, that we are able to do these shapes, and also on a more micro scale that we will be able to do patterns and reliefs and kind of these textures in the walls. And I'm also sure that a lot of different functionalities will slowly begin to be, you know, embedded into these 3D printed structures, right? I hope that answers your question. If not, please elaborate.
It does. It's exciting because it's the dawn of something amazing to come. So we start to see curved walls little by little in the buildings that we see around the world, and that's that's just the beginning.
Yeah,
right?
but it's quite interesting, right? That we have this construction method now. That, you know, the 3D printer, it doesn't care if it's round walls or if it's straight walls or whatever it is, right? So we have these, you know, endless opportunities, and then we still see squared houses, right? Which is quite interesting, actually, to some extent, right? Like we are still trying to just match something familiar and try and have something that we can compare to the conventional methods, actually, even though there are so many possibilities with this, right?
Yeah, and the market is also in development. So the taste of people, I think it's always to the normal box as well. So as the design evolves, people might want to get a little bit and ask for other things than what they're used to. So I'm sure we're going to see that in the future. So thank you so much for that answer. We're going to go with question number 2. So how is this technology greener, like friendly, more ecological, than traditional construction? You spoke a little bit about deposition instead of subtraction, which would be the normal way to go. But if you could just please tell us more about that.
Yes. I think, you know, it's a very broad question, right? How is it greener overall? I think there are a lot of different things that, you know, has a say in this case. It depends on where you are in the world, what kind of materials you're using, what is the structure that you're making. For example, as we talked about, if you're doing a very, very complex structure, it would be a lot easier and a lot less wasteful to do it with 3D printing compared to if you were doing it with, let's say, formwork or other things like kind of, structures like that. But if you do compare, let's say, a completely squared building, it might even be, you know, easier or greener to do it with conventional methods as it is right now, right? I would say just the point of that is that the more complex our structures begin to be, the greener it will actually be to 3D print them, right? I would say there are 2 main things that are kind of like universally greener, which is transportation. We don't need to transport a lot of components to a building site that we then have to assemble from different sites. That's one thing that I consider to be a really, really good point to go into this kind of construction, right, or focus on this. And another thing is material waste in general. Like usually we have a lot of material waste on building sites, and here we only deposit and use, like we only put the material down where we need it, right? We don't need to cut things into the shape that we need exactly, and produce a lot of waste in that kind of sense. And that's just one thing on the material side, and I am sure we will probably hear more from Hannah about this, hopefully, maybe. But there is so much going on in material science, where I definitely believe that we will start to move more and more away from conventional concrete, where on the material side we are just competing with conventional building methods material wise on the large scale, for like actually applied and permitted buildings right now. But I definitely believe that with material science and new materials being kind of developed, that will just increase the ecologic benefits of 3D printing.
Okay, thank you so much. So now we're not just gonna say that the sky is the limit, but now it's like the universe is the limit. So that's pretty amazing. Making the connection with that that node where you said material is the frontier in all the possibilities that we're gonna have in this amazing industry as women, as professionals. I think we can jump to Hannah. And now Hannah, as she mentioned in her previous presentation, she specializes in materials, and she'll tell us a little bit more on biopolymers. So we know, Alma, that we are using concrete and all of these ecological materials at this point, but there are also the other parts of the construction, right? The switching of the light, the piping, all the other materials that are part of construction as well. And I'm sure Hannah will tell us a little bit more about that. Now, thank you for explaining what a biopolymer is for the audience and what the Mediated Matter Lab group is. I think that's something very unique. We know we've seen the Netflix special on Abstract about the laboratory, so that's pretty exciting. And the first question that we obtained for you was, how do you see biopolymers replacing plastic in the upcoming years? And we know the MIT has this vision for many decades to come. So if you would like to share your vision, we would really appreciate it.
Yeah, that's a great question. So I'll refresh you all on what polymers are. They're biodegradable materials that are sourced from nature. So we're essentially getting plastics from agricultural byproducts. So normally materials that are put to waste, finding a purpose for them. So my lab in particular sources our ingredients from plant manufacturers. So we get cellulose, we get pectin, which is found in fruits, and we use chitosan, which is found in crustacean shells and the cell walls of mushrooms. So all these ingredients are very essential in forming structures in nature. So they're very sturdy to make actual materials for construction out of. So the main selling point for biopolymers is their sustainability. Being biodegradable and natural means they're non-toxic and can prove wonders for reducing waste that just goes in landfills. So one of the uses for biopolymers, I think of prototyping on a traditional FDM printer. Since when you're making designs, you might be throwing out so many iterations of your prints because the tolerances aren't right or the print just turned out pretty bad. So you're putting so much waste in the trash. But if you can make drafts or just prototypes from biopolymers, then you don't need to worry about constantly iterating when you just have all your different parts that can just decompose naturally. So a big selling point people use for PLA is that it's biodegradable. But they don't tell you that that's not on a human time scale. It takes so many years. So all of your traditional maker prints are just going to be sitting in a landfill for hundreds of years. But if you use biopolymers, they can decompose in a week. You can grow plants from them. You put them in the soil and they just blend into the environment. So you don't need to worry about the landfills filling up. And then you could also recycle your stock, similar to how you recycle like resins, leftover nylon with SLS and SLA. So you can reduce a ton of waste in your manufacturing process. And overall, your design process will be a lot smoother and more efficient, while also being eco-friendly. And on a much larger scale, biopolymers can be used in packaging, which is something that I've been really curious about this past semester, since I was opening so many packages of tools for my mechie classes, and I was just so horrified at how much plastic I was throwing out. Like every wrench, every screwdriver was encased in just so much material. But biopolymers could replace that plastic. What's great is that they can deform under heat. So you can thermoform sheets of biopolymers in manufacturing so that you can take a sheet of plastic made from biological material and it will conform down to whatever you're trying to package, just like normal plastic. So there's a really cool company called Shellworks in England that sources chitosan by just going around to local restaurants and getting their leftover lobster and shrimp shells, and then in-house manufacturing biopolymers that they're using for packaging and cups and containers. So I see that, and I can imagine just walking through the aisles of Home Depot or the craft store or any local store, and all the products on the walls are encased in material that you can throw away and know that it will do no harm to the environment. In general, biopolymers can be used for like any sort of construction project. I've seen labs making joints and chairs, and I know a bunch of car companies like Ford are introducing more biological materials to combine with their current plastics. And then the medicine, like medical industry, could deserve a whole panel on its own because the biopolymers are non-toxic, so biologically compatible, used for tissue engineering. It's fascinating, creating organs from scratch, or dressing wounds for burns, skin transplants, delivering drugs. So that's fascinating how many applications there are. And every day there's so much more research building upon what we've already discovered. So I'm really excited to see where biopolymers go and just how sustainable we can make our future using them.
That's really interesting. Thank you so much. I don't think we talk enough about packaging in construction. We focus on the structure, we focus on the design, we focus on all of this regulatory and just to get the building there. But once it's there, you need to detail it, and that has a lot of components that come in packages, and we, are part of this waste that Alma mentioned. So how that will transition in the future is something definitely interesting that we look out to see further of your work in the construction field in the future. So thank you so much for that. Now, we speak about 3D printers, and we know 3D printers today, but then in this type of labs, we've seen machines that have multi-injectors. And we're really excited to understand what's the vision of multi-injectors for the construction of the future. We know there are elements in 4D printing, so there's a lot of information of the projection that the industry has for the upcoming years and the great work that is being done today. So if you could tell us a little bit more about the multi-injectors in 3D printers for the future of construction, please.
Yeah, of course. Multi-material printing is really fascinating. So when you think of your traditional 3D printers, you're extruding one material. If you use a desktop, you extrude PLA filament, and you make a solid object that, it doesn't have much complexity because you're only using one material. And if you want to add on to it, you have to switch out a cartridge, switch out the spool of filament. So you have pretty basic prints. There's no mixing, there's no gradients of different materials. So when my lab has wanted to make complex prints in the past, we have been layering materials where we manually switch out the cartridges. And we just hope that the materials, when they're next to each other, on top of each other, blend and bleed together. But we ultimately have no control over that process. And our prints are relatively simple. So to take like your designs a whole new step further, you use multi-material printing, which is where you're printing multiple materials simultaneously. You could have multiple sources of materials all extruded through different nozzles, or they can be blended together in one nozzle. And this allows for way more complex prints because you can make gradients from one material to the next. And then you could determine what your composition looks like at each point of your print. So with biopolymers, this means we can code the properties of what we print. So if we want to blend a rigid material with a flexible material, we can create that gradient as the multi-material printhead mixes the materials together. And you could definitely define each part of your product, how you want that to behave under pressure, when picked up, when folded. So it's really cool. And this is especially crucial with the biomedical industry because tissue engineering becomes so much more lifelike. You go from printing a single material, making a basic ear, it looks like an ear, but then you could go to multi-material printing and carve blood vessels and create realistic tissue by blending different materials together. So it's truly revolutionary. And you could also use that similar process with electronics if you want to control how your material conducts electricity.
So that's going to be a very important point because electronics are part of the system of a house or a building in general. So how we use those gradients and how we use that flexibility that multi-injection provides to the industry will help revolutionize the way we perceive buildings today. So I think that's a great idea or general idea of how this will evolve in the future of construction and certainly in medicine and other sectors. So we really cannot wait for the benefits of that. But we really thank you for that insight. And I'm sure we can get back to you on materials because we have a lot of Q&A questions at the end of the panel. So that's great. Your laboratory is doing amazing things. And from the pictures that we saw in the beginning, we were very able to see those gradients. So how that translates to architecture, can't wait. So thank you so much, Hannah, for those amazing insights. And
Thank
now we're gonna go to Agnès. So Agnès, thank you so much for your introduction. It was very interesting to know you. You're the founder as well. Anna is the founder of, co-founder of Apis Cor as well. So it's always really exciting to see women leading the industry. We're all here because of that, but you know, that has some business aspect to the equation. It adds some business aspect to it. So we have these questions from the general public as well that state, what are the basic skills that you could recommend to people that is starting or wants to join the industry required to have a career in 3D printing construction? If you could share a little bit of your experience with the audience, please.
Thanks, Sofia. So as you have heard, my background is not a straightforward line in construction. And I think this is, today, everyone can switch the career path at any time. What is important is the consistency of this career path, and maybe taking my experience or my path is, as I started in working in resources and raw material sourcing. Why I started that? Because I wanted to understand how our sourcing of raw material impacts the industry and social economical aspect. I moved on then to space science because I was passionate since time, and I wanted like have a more microscopical view on not only on how our resources are used, but also rather on how resources are appearing in the solar system. And then naturally, I wanted to come back to the industry, and I came back to the construction. After again a couple of years in the construction industry, so in the construction material industry, I went to a more applied. And for this, I had the feeling that I have 4 lives in my life. And what is important is that at each stage, also in the construction industry, or young ladies can not switch after a year or 2, but really can have achievements, can prove that what they have learned, gain credibility in their field. And this is, I think, not only for construction or 3D printing, but in general, it's quite important for young and new generation to really explore a topic from A to Z, maybe at a different speed, maybe in different level. But what is extremely important, and I think as an entrepreneur, Anna can say the same thing, is that when you hire a person, what you expect this person is to really not only bring the passion, but really to have a certain knowledge bringing in the company. Maybe from the construction industry, and we were sharing this types of thoughts before, is that in 3D concrete printing, we are always competing against traditional business. The understanding of how do you construct today, not only buildings, but infrastructure, how do you do the drawings, how do you do the detailed execution plans? And I think everyone that has been on a job site know that there's what architects are designing, but then there's execution plan, and at last there's what is really realized on the job site. And these are 3 realities. If in the construction you do not know this, you will not be able to cope with issues that you might have afterwards implementing new technologies. So really understanding, a profound understanding of how people are building today, how are they designing, how the traditional method, I would say, is absolutely essential in order to innovate, because otherwise you do not have the understanding of where is the potential and where are the entry barrier points. Of course, learning this does not mean accepting that doing the same traditional way, and it means also that you have to provide your own inputs and optimize the methods, construction method, design methods. But for me, the credibility is absolutely key. And women in construction, I think this is there are 2 topics: women in construction, women in 3D printing, and this is not necessarily related, because 3D printing can be any types of material. I would say that the typical aspect of construction is that a woman will be always more challenged against their male colleagues. And also probably as a CEO and founder, I'm evaluating basically candidates not only about what they can, their background, so what I just said before, like the credibility of what this person has achieved in his or her career, but also about what is the passion, what is the vision, and to bring their own, I would say, innovative aspect, and to pursue their own, I would say, commitments, and have really a belief on, I will change one aspect of this of the industry. So I think this the skills, in terms of skill, bringing any types of skills, as long as it's credible, it has been deeply applied together with passion, is the most important one step and first step to enter the business.
I am sure our audience will benefit from that amazing advice. So we have passion, vision, your own contribution to the industry, and the confidence that because has already started, you can be part of this amazing wave that is revolutionizing the construction field. So thank you for that. We have a second question that is specifically in founding your 3D printing company, and it is what inspired you to create a company in this space? You mentioned a little bit of what you saw or lived with your husband, all of these delays, and that it had to be a better way. So if you could share a little bit
sure.
of that, please.
I think it's not from one day to another that you wake up and you say, oh, I will found a company and this will be a 3D concrete printing company. I think it's a path, it's experience. It's that's what I said. You have experience in one field, and you have to test whether you have affinities with this field. So from my personal experience was, as I said, well, my I would say reaction 16 years ago. So before entering the construction, I said, no way that I will enter the construction business. It's so inefficient. I was, it's Anna, you were doing space science. So you working in space science is so sexy. It's just your, I would say, the top of group working on extraterrestrial material. I thought, how can you do any research in concrete? And then I applied. I had a friend that told me, well, look, if you really want to find a job in the industry, just try there in the construction because you have some affinities of raw material. And I applied there. And I remember my former boss told me, I see you in research and innovation in the construction industry. And I told him, look, I've been doing research and innovation in space science, but what can you research in concrete? I mean, concrete is the material that is used since 2000 years. So you have nothing to search for. And actually I was really wrong, because what I really underestimated.
Like, what can you research on concrete?
Yes, exactly.
Yeah. Continue.
Yeah.
Sorry.
So that question, I thought, yeah, you cannot research because it needs to be a material that is well known. It's worldwide used. It's the second most worldwide used material, right? And I was really wrong. What I see today, and this is also quite intriguing. There's kind of two levels speed in the construction industry, where you see people using this material worldwide, which do not know how to use it. And looking at this concrete material, what you see is it's a highly technical, highly chemical, chemistry is highly involved in the way concrete behaves, fresh concrete and hardened properties. And there's still quite a lot to discover and to understand there. But these two levels is basically what we see is that in the academic world, you have a lot of women working on building materials, understanding the chemical behavior of concrete, physical behavior, and researching on that. And there's a second level of I would say, where we are using this material without knowing exactly what happens between the particles, between the minerals. And there's a big gap between these two levels. And I would say, I think that's where women can do a difference, is that there's a lot of women in searching and searching in R&D in building materials. And if they this next step to a more applied environment, they can really bring a lot of their understanding of the material, of the complexity of this material for the construction industry. And I think construction 3D concrete printing is, as we said, there's quite a lot of complex behavior in the 3D, in the process itself, but also in the raw material, quite a lot of research, but it should stay on the academic level. It should be highly applied. Sorry, I entered in this field because for me, it's really intriguing to see how these two, I would say, worlds evolve parallel and sometimes do not speak to each other. And it's absolutely really key to have applied R&D in concrete and construction. Also for construction methods, like 3D concrete printing is one method, but basically what I believe is that there will be different processes that will emerge from 3D for each application, and this you cannot have and you cannot evolve through that if you have only one angle of looking at this technology, but having several angles of tackling the technology, but also the material and the construction processes.
Definitely. So thank you so much for that. That opens the floor for understanding a little bit more of this multidisciplinary universe, where we are, we already have all of these companies integrating people from different fields. Sonya mentioned in her introduction that she herself wouldn't see herself in this industry at the beginning, but now it's totally captured by it. We're gonna just go with one of the questions from the audience. So we have Audrey van de Castle. Where do you see the most viable near-term use for 3D printing in construction? So I think everyone spoke a little bit about infrastructure and housing. I don't know if there are other areas that, well, Agnès, I think you do some works for piping. So I don't know if you want to develop it a little bit on that, and then we'll go back to Sonya. Okay?
Yeah, maybe very briefly, why did we start it in utilities is because what we see is, I've been working in utilities before, and every infrastructure project is unique. Basically, and what even today with building information modeling, what we are trying is to foresee what is coming, and in buildings you can really plan what is coming. And this is really not infrastructure is happening. Every infrastructure project is unique. Every underground is unique. And personally, I believe that the very first application in underground economical return on investment also, and this is where it's solving a small issue, but this is one step, and one step after another, the adoption rate can increase. So I would say low risk product where uniqueness is the advantage of the process, but also where the integration in the value chain, and I think Alma was saying that, is that it's not only about the 3D printing, but it's how you integrate the process in the value chain and how you modify the value chain. And that's why personally I believe utilities, infrastructure, underground application is a first step. But I do believe that also technical buildings, like of course it's nice to build huge buildings, but I think also smaller technical buildings will be much more also for the owner of the building and contractor, low-hanging fruit to enter in this business. But maybe other people panelists want to answer.
Thank you. So utilities is one. We've seen the Dubai building. We've seen building beyond Mars for scientific, in Mars and the Moon for other purposes, research. The other fields that we have seen as early adopters are also furniture. So I guess all of these elements add up. So at the end, we all have integrated parts of the technology, and the community can start to adapt it in many different sectors, not only the housing sector, but also other fields, which benefits us all. We have some questions from the audience related to your background. Mm-hmm. And we also want to understand, how do you see on your day-to-day women interaction, not only as the professionals in the career path, but also as the people reaching out to understand more about the technology. So the first question we have is, besides design and construction, which other career paths exist in this sector?
The other option that I tell people, we have a distributor program. They're able to sell the printers in their area. It's their own business. $10,000, they can have their own business. Salt Lake City, UK, if we go across the entire world. So, and you can't even start a perfume line for that cheap. So we give them everything that they need, every single tool to achieve that and become a successful businesswoman.
So much. So to consolidate that, it means that, you know, you're not only on the construction side of it, but you can also reach out and start your own business and be involved in other sections of the technology, which is always great. So really appreciate that. And this is the last question, so we're gonna kind of wrap up. How is this community different from a typical construction crew? So traditionally, women are involved in interior design because, you know, of the background where historically you had to be very strong to build the structure, the shell structure. So this technology allows women to also be involved in the process of building the shell, which is really interesting. You mentioned you could carry part of the structure of the 3D printer by yourself. So I guess there are many other ways to participate in this first stage of construction that we didn't have maybe in the past. So thank you for that. So thank you everyone for your time today. This amazing speakers, thank you so much for sharing this with the world, the students community, and everyone that is very enthusiastic about this technology. We're now going to proceed to the networking space where people will be able to reach out to you and talk to you directly. So thank you everyone. Sanjana, would you like to comment on the program of Women in 3D Printing just for our students audience, please?
Sure. Thank you so much to all the panelists again for sharing your experiences. And thank you, Sophia, for being such an amazing moderator. So I just wanted to highlight a couple things about women in 3D printing. But first of all, I'd like to send a big thank you to all our sponsors. Without our sponsors, this event would not have been possible. And we also have a couple of announcements. So the first is that the Women in 3D Printing Next Gen Mentorship Program is still open. So please feel free to use the QR code to access the application. We meet quarterly, and it's a really great way to get to know some of the people in the industry, as well as just learn more about 3D printing. I'd also like to highlight the job board, which is constantly being updated with new opportunities, so also feel free to check that out.